Hello everyone, welcome to today's class. Like we have started a topic on indices where we have solved problems that involve numbers in indices. Now we are going to continue with questions or with type of problems which involve algebra, starting with simplification first, then we now move to equations, okay, where I have already explained that it can lead to linear equation, quadratic equation, simultaneous equation. Okay, so let's start with the simplification part. So look at this question that we have here. We are asked to simplify this. Okay, so this is our number one. We are asked to simplify a question like this. What are we going to do? All you need to do is to apply laws of indices in every alphabet. Okay, take care of the numbers, take care of the alphabet. Please, when I mean take care of the alphabet, I don't mean that you should use A to cancel out B. No, A should take care of itself, B is going to take care of itself, and C is going to take care of itself. Okay, though they are together as a number. Okay, so let us work this one out. So I'm going to have my square root. Okay, let me write the numbers. 2 here, 72 over 2, a square, a raised to power minus 3, b minus 3, b, c raised to power 4, and c raised to power minus 2. Okay, so first of all, let me take care of this number. This will give me 36 here. Okay, now I can apply law of indices in this particular alphabet. So that will give me square root of 36. Let me take care of A. A will give this divide. So divide means minus. So that will give me A square minus 3. That's my A. Okay. Now coming to B. B will give us B minus 3. This will give us minus 1. That's my B. Now let's go to C. C will give us C 4 minus 2. Okay, so that's our C. So we can see that the number is becoming simpler. Now that will give us, this will give us square root of 36, a raised to power, this will give us 5. Okay, this will give us b minus 4, and this will give us c 6. Okay, so at this point you can take your square roots if all the numbers are perfect squares. If they're not perfect squares, you can actually change them to indices. Okay, what I mean by changing them to indices, remember one of the laws, we say that if you have n a, that will give you a1 over n. So with this, you can actually change everything there. Those ones that are not perfect squares, you can actually express them in this form. So let's finish it up here. So square root of 36 will give us 6. Okay, then this one, square root of it will give us a5 over 2. Then for b, that will give us b minus 4 over 2. Then for c, that will give us c 6 over 2. So with all these now, I have a 5 over 2. This will give us b minus 2. That will give us c 3. Okay, remember minus here simply means 1 over. Okay, because we know that 1 over a will give us a minus 1. So with this now, we can apply it here. So that will give us 6 a 5 over 2 c 3 all over b squared. So b is coming down now without the negative anymore. So this is the final part or final answer to that problem when you simplify. Okay, so let us look at another example. So this is another type of question that you are likely to see. In this kind of question, all you need to do first is to make sure that you put everything in its lowest base. Okay, so 2 is already in its lowest base, so you have to make 4 to be in its lowest base, then you have to make 8 to be in its lowest base. Now, what I always tell students, that whenever you have a compound number, okay, as the index, that you should put that compound number in a bracket. Since it's not a single number, so just put it in bracket. That will help you not to make unnecessary mistakes while solving your problems. Okay, let's do that now. So that will give us, let me first of all put these things in brackets. So that's what I mean by putting those things in brackets. Times 4 is the same thing with 2 raised power 2, open bracket, and write my 2 minus y, all over 8 is the same thing with 2 raised power 3, open bracket, y plus 3. Okay, so this is what I mean. Then the next thing now is you can open your bracket for the index, or you can actually leave it like that. Does not really going to change anything. So the next thing to apply is law of indices here. After that, you now take care of division. So let's do that here. So that will give us 2 into 3y plus 1. Multiplication, the same base will give you will give you plus 2. 2 is outside there, into 2 minus y, okay, all over 2 into 3 y plus 3. You can actually do the division at the same time, but in order to be more careful, so that's why I'm doing it this way. Okay, you can actually bring your division index, bring it here as minus. Okay, so let's go up here and finish that up. So that will give us, you can open your bracket first, whichever way you want to do. If I'm the one solving, I will do everything at the same time so that I can be able to save time while solving question in examination. So let's do it step by step for now. So open this bracket. So I have 2 into 3y plus 1. So open this up bracket here. I have plus 4 minus 2y all over 2 into 3y. I'm opening this bracket here, plus 9. Okay, so that will give us 2 into 3y minus 2y will give me y. Then this and this will give me plus 5. Okay, all over 2 into 3y plus 9. So I can put all these in bracket also. So you can bring it up now. When you bring it up, remember an over am will give you an minus m. So that will give you 2 into y plus 5 minus 3y plus 9. Okay, so that will give us 2 into y plus 5 minus 3y minus 9. That will give you 2 into this, and this will give you minus 2y. This and this will give you minus 4. Okay, so you can simplify further to have it as 2 into minus 2y plus 4. Okay, you can as well bring your 2 outside. So of course you can play around it now. So that will also give you 1 over 2 into 2y plus 4. Okay, so you can stop here. You can actually bring out 2, which is common. So when you do that, if you decide to bring 2, which is common, you're going to have 2 into 2. Okay, let's have it like this: 2 into minus 2y plus 2, which will give you 1 over 2 raised to power 2 is 4 into y plus 2. So whichever way you decide to leave your answer, that is perfectly correct. Okay, but please, when you're in the examination, you have to learn how to skip some steps, because some steps are not going to actually attract any mark for you. So immediately you have gotten to this point, you can as well go straight and as you are taking care of multiplication by adding the index, you can as well subtract the index of the denominator. Okay, since they are all now in the same base. Okay, so let us look at example 3. Remember, we are doing simplification, so we are just simplifying. Now look at this question. Okay, so what are you going to do here? Please, this is where I need to say something very important. Whenever you have, let's say, 2x raised to power 2, this power 2 here is going to affect everything inside this bracket. So what does that mean? If I want to open this bracket with this power, I'm going to have it as 2 square s square, okay, which will give me 4s square. So that's what I'm going to have. So because this question here, as you have 3 here, this 3 is going to affect both 2 and also what? X. So that will give us 2 raised to power 3 into x squared raised to power 3. So you can see that every number or expression inside that bracket have partake from the power. So that will give us, here is 8. This one will give us x raised to power 2 times 3, 6. So that's just that. Very simple question to solve. Okay, so let's look at another example. So look at our number 4 question, very tricky one. That's one of the examples from the IGCSE exam. Okay, so you have 3125 W raised to power 3125 all raised to power 1 over 5. Okay, so the question now is that what is this number? Okay, what is the lowest base of this number? That's the first thing to ask. Okay, because when you get the lowest base of this number, you can now be able to say, okay, let me express it in this lowest base, or let me express it in that lowest base. Okay, so this number, of course, a number that is ending with 5 will definitely have 5 as lowest base, which is far beyond what I stated in the previous video about they cannot exceed, because I think I said they cannot exceed 625. Okay, but we can see that they actually got up to 3125, which is 3125. So let's see how many 5 raised to power will give us 3125. So 5 times 5 will give us 25, times 5 will give us 125, times 5 will give us 625, times 5, okay, that what is going to give us 3125. So that's 1 2 3 4 5. Therefore 5 raised to power 5 will give us 3125. Okay, so with this knowledge now, we can have this as 5 raised to power 5 W 3125 all raised to power 1 over 5. Just like what have happened here, this 5 raised to power 5 is going to take part here, and this W raised to power 3125 is going to take part there. Okay, so with that, we are going to have 5 5 all 1 over 5. So it have taken part. Then we now have W raised to power 3125 all raised to power 1 over 5. So this will give us just 5. Then here we need to divide 3125 divided by 5. So we need to get the answer 3125 over 5. 5 here will give us 6, remember 1. 5 here will give us 2, remainder 2. 5 here will give us 5. So that will give us W 625. Okay, so that's our answer there. All right, so we have solved about 4 simplification or 4 problems under simplification. Now I think it's time for us to look at the ones that will lead us to linear equation, the one that will lead us to simultaneous equation, and probably the one that will lead us to quadratic equation. So this is our first equation we are going to solve. Is a simple equation, of course, going to lead us to linear equation. Remember, in equation or in solving indices equation, all you need to do is to make sure you simplify the left hand side and make sure you simplify the right hand side. And most of the time, when you simplify the left hand side and simplify the right hand side, you have the same base. And when you have the same base, you equate the index. That's what we do. What I mean is that if I have 2 raised power s equals to 2 raised power y, since the base are the same, it simply means that x is equals to y. So this is actually what we actually do there, okay, or what we are going to be doing in equations. So let's apply that here. So put this in lowest base. Now putting 4 in lowest base as 2 will not actually, it just prolong the solving of the problem, okay? Because 16 can actually be, we can actually put 16 in base 4, which is 4 raised to power 2. But if you don't want to solve like that, you can as well use 2. So let us use 2. This will give us 2 raised to power 2 into 3x equals to 16 will give us 2 times 2, 4 times 2, 8 times 2, 16. So that will give us 2 raised to power 4 into x plus 1. Okay. So when you take care of this, you have 2 raised to power 6x equals to 2 raised to power 4x plus 4. So you can as well cancel out the base. Since the base are the same, just like what we did there, the base are the same. That means the index are what? The same. So that will give you that 6s equals to 4x plus 4. So bring this one over here. 6s minus 4s equals to 4. That will give you 2s equals to 4. Divide both sides by 2. So 2x over 2 equals to 4 over 2. S equals to 2. So that's how to solve that particular type of problem. It's a very simple one. Okay. Let's go over it again. You can ask, okay, let's solve it. Let's solve uh if we decide to put 16 in base 4, okay, so that will give us 4 raised to power 3s equals to 4 raised to power 2, that's 16, into x plus 1. So 4 and 4 will go, that's the same base, okay. Since they are the same base, it's not that we are cancelling it out that maybe we are dividing. No, we are not dividing. Rather, this is the principle we are using there, that if the base are the same, it simply means that the index are the same, so long as this is equal to this, okay. So that's the principle that we are using. So if the base are the same, it simply means that the index are what? The same. So 3x equals to 2 into x plus 1. You can open your bracket. You have that 3x equals to 2x plus 2. So 3x minus 2x equals to 2. This will give you x equals to 2. So you can use any method you want, okay, and solve your problem. So let us go to the second equation. We are going to move a little bit away from this level and come up a little bit before moving to the one that will lead to simultaneous equation. Okay, we have two questions now, so I want us to solve them at the same time. Okay, um look at the first one. The two questions there, they are almost alike, but the only thing that caught my interest in this third question is that uh, there is a square root at the index, okay, which is quite interesting. So let's take care of the second one first. So solution here. Now, when you look at, there's no index here, or there's no index here, but you can actually express these numbers here in indices, okay. So when you express it as indices, you find out that it's going to still give you base 5. We are going to see that now, okay. So let's solve number 2. Number 2, we have 5. Let's apply law of indices here. That will give us 5 raised to power 2x minus 1 plus x plus 1. So we have taken care of these two. Now let us come here. 0.04 is the same thing with 4 over 100, okay. So 0.04 is the same thing with 4 over 100, which is the same thing with 1 over 25, which is, of course, is the same thing with 1 over 5 square, which is the same thing with 5 raised to power minus 2. So you can see This number is the same thing with 5 raised to power minus 2. So we'll come here and we put it there, 5 raised to power minus 2. So we can remove our base, and we have x 2 into x minus 1 plus x plus 1 equals to minus 2. So open your brackets, you have 2x minus 2 plus x plus 1 equals to minus 2. You collect like terms. This and this will give you 3x equals to minus 2. Minus 2 here cross over, I have plus 2. Plus 1 cross over, I have minus 1. So that will give us that 3s equals to minus 1. So divide both sides by 3. You have that s equals to minus 1 over 3. So that becomes the answer of that one. Now let us move to the third question. So for the third question, I have 2 raised power square root of 2x plus 1 equals to 32. 32 will give us 2. Okay, let's try it out. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. So that will give us 2 raised power 5. So this here will give us square root of 2x plus 1 equals to 5. So you square both sides so that you can be able to remove the square root. So I have square root of 2x plus 1 all squared equals to 5 all squared. Square and square root will go. I have 2x plus 1 equal to square of this is what? 25. This one coming over here, 2x uh 2s equals to 25 minus 1. So 2s will give us 24. When you divide both sides by 2, you have that s equals to 4. Okay? You have that s equals to 12. So you can see that as hard the question is looking, is not difficult at all. Okay, so we are going to solve maybe one more question on simply on linear equation or indices leading to linear equation. Then we now move to simultaneous equation before looking at quadratic equation. In our question number 4, you can see how quadratic is looking, but don't be scared. All you need to do, simplify this, put this one in lowest base, and it is very simple. Now, this time around, I'm not going to do this, and we have done something like this in simplification, so it will be easy for us to do that now. So that will give us these two will give us 2 into 1 minus y plus y minus 1. Okay. Then this one will give us minus y plus 2 equal to this one here will give us 2 raised power 3 into 2 minus 3y. Please, I hope that you be able to follow what I did. These two is addition, division, this over, so it's division. Division is what? Subtraction. Now, since I have this, I can cancel this and this. The base are the same, therefore the index are equal. So it simply means that 1 minus y plus y minus 1 minus y minus 2 is equal to 6 minus 9y. Okay, so you can collect like terms now. Minus y plus y will go. So this one will come over here. I will have minus y plus 9y equal to. So what I have done is that because plus y and minus y will give you 0, so I cancel that out. And 1 and minus 1 will also go. Okay, so I have only y. So this one coming over will become plus because it was minus equal to, I have 6 there. This one moving over will give us plus 2. So these two here will give us 8y equals to this one will give us 8. Divide both sides by 8. You have that y equals to 1. You can see that the question is not difficult at all. Okay, so you can look out for some questions on integral equation leading to linear equation and try your hands on them. So the next question we are going to look at is the one that will lead us to simultaneous equation. Okay, and what difference does it make? Linear equation, simultaneous equation is just that you are given this equation two places to solve at the same time. Probably having two variables, because when you have two variables, you cannot use one equation to solve. You need another equation, another information about the two variables, so you can be able to use it and solve. So let us look at the ones that will lead us to simultaneous equation. We are going to solve two problems that will lead us to simultaneous equation. So this is one of them. Why I say two problems is because this one, if you look at it very well, only the first equation is in indicia form. The second equation is not an indices, okay? So what are we going to do? Make the first equation to be a linear equation. Then you can solve simultaneously, okay? So solution, this one here, 9, 1 minus x equals to 27y. We can express them in lowest base. So that will give us 3 raised to power 2 into 1 minus x equals to 3 raised to power 3y. Okay. So this and this will go. So that will give us 2 minus 2x equals to 3y. Okay. So if I, which way should I take it? Okay, let me bring this one over here. If I take this one over here, I'll have that 2 equals to 3y plus 2x, which you can write as 3y plus 2x equals to 2. So with that now, I will now say therefore 3y plus 2x equals to 2 as our equation 1. Then this one, okay, this one I have x minus y equal to, this will give us minus 3 over 2 equation 2. All right, so what are we going to do? Let's multiply this equation by 2 so that it will look like this. So this times 1 and this times 2. And let's rearrange. You can as well rearrange. Why am I rearranging? I like my x and x to be together and my y and y will be together. Okay, so doing that, I can have it as 2x plus 3y equals to 2. It's still the same. I'm multiplying by 1. So 2 times this one will give me 2x. 2 times this one will give me minus 2y. And 2 times this will give me minus 3. Okay, so since this is what I have now, I can easily eliminate by subtracting. So this minus this will go. 3y minus minus 2y will give me 5y. 2 minus minus this will give me 5. So when I divide both sides by 5, I'll have y as 1. So I've gotten the value of my y, so I can put it anywhere and get the value of my x. Let's put it in equation 2. So put y equals to 1 in 2. So these two, anywhere I see y, I replace it with 1. So I'll have that x minus 1 equals to minus 3 over 2. So this one coming over here, I have x equals to minus 3 over 2 plus 1. Okay, if you're allowed to use calculator, you use a calculator and press and get your answer, which will give you equals to minus 1 over 2. So therefore, s equals to minus 1 over 2 and y equals to 1. Our sixth question, you can see that the two equations there are in the sharp form. So I can call this one equation 1 and call this one equation 2. So my job here, or the first job I have, is to make these two things to look like a linear equation. Then I can solve simultaneously, just like we did in the previous example. Now I will say from 1, okay, from 1 I have 2x plus y equals to, express this as a base of 2, so that will give us 2 raised to power 4. So do this, I have x plus y equals to 4. Let me call it my equation 3. Okay, now I will also do the same from 2. Okay, express this as a lowest base. So I have 2 raised power 2 into x minus y equals to 1 over 32 will give us 2 raised power 5. So that will give us 2 raised power 2 into x minus y equals to 2 raised power minus 5. This and this will go. So I have 2 raised to power 2x minus 2y equals to minus 5. So I call this equation 4. Okay. So I'm going to solve 3 and 4 together now. So that will give me x plus y equals to 4 and 2x minus 2y equals to minus 5. So let's call it, this is our 3 and this our 4. So elimination method, I will multiply this by 2, this by 1. So that will give us 2x plus 2y equals to 8 and 2x minus 2y equals to minus 5. Okay, so you can eliminate anyone now the way we are seeing it. So anyone you want to eliminate, you can eliminate. If you add, this one will go. If you subtract, this one will go. So let me add. If I add, this and this will give us 4x. This one will go. This and this will give us 3. So we divide both sides by 4. S equals to 3 over 4. Now we have gotten our x. The next thing is to get our y. So where can we put it? Equation 3. So y, put x equals to 3 over 2 in equation 3. Why do I choose equation 3? Because you can see equation 3 don't have a lot of numbers that will give us issue. So you have 3 over 2 plus y equals to 4. So take this one over here. Y equals to 4 minus 3 over 2. So y equals to 5 over 2. Okay. All right. Therefore, s equals to 3 over 4 and y equals to 5 over 2. So that's our answer. Now, we are going to solve just one problem of the one that will lead to quadratic equation. But if you are going to solve that with me, I hope that you have watched my videos on quadratic equation. Okay, because if you have not watched my videos on quadratic equation, or you don't know how to solve quadratic equation, at a point you might miss out. Okay, because you might not understand what is going on again. Okay, our example 7 is going to actually lead to quadratic equation. Okay, now sometimes students ask, how are we going to know that is going to lead us to quadratic equation? One place that they will not give, or they cannot be able to hide it, is that you will see 2x and you will see x. You will see 2x and you will see x. I'm not saying that x here might be alone. No, it might not be alone. Okay, we can have 2 into 2 2x plus 9 into 2x plus 1. They cannot hide it. So you can see your 2x, you can see your x. Okay, so whenever you see an expression of that nature, that you have a term that has 2x or 2y, whichever variable they decide to use, and you now look at the other one, there is just x, suspect that is going to lead us to what? Quadratic equation. So let us see how this one will lead us to quadratic equation. So I have my solution. Now I'm going to apply law of indices here. Okay, this time around in reverse order. What do I mean in reverse order? If I have ax plus y, it simply means that I have ax times ay. Okay, I'm going to have 2 raised power 2x times 2 raised power 1, okay, minus 9 into 2x plus 4 equal to 0. So this will give us 2 into 2x minus 9 into 2x plus 4 equal to 0. Now for this one, remember that an into m will give us an times m. Okay, so if you do that here, you have that 2 into x squared, okay, minus 9 into 2 raised to power x plus 4 equal to 0. So we can now say let 2x equals to a. So that will give us 2a squared minus 9a plus 4 equal to 0. Okay. So with that now, we can solve this using quadratic method. So I think it's factorizable. So let us solve it using factorization method. So that will give us 2a squared minus 8a minus a plus 4 equal to 0. Okay. So that will give us 2a squared minus 8a minus a minus 4 equal to 0. So what is common here? 2a is common. So you have a minus 4 minus a minus 4 equal to 0. So that will give you that a minus 4 into 2a minus 1 equal to 0. Where do we get this one from? There's one here, which we don't normally write. Okay. So solving further, therefore, a minus 4 equal to 0, or 2a minus 1 equal to 0. So a equals to 4, or 2a equals to 1. So a equals to 4, or a equals to 1 over 2. So we are not done. We have just gotten a, but remember, a is the same thing with what? 2x. So let's put back our a. So recall that a equals to 2x. Therefore, 2x equals to 4, or 2x equals to 1 over 2. So you express everything as an index. So you have 2 raised power x equals to 2 raised power 2, or 2 raised power s equals to 2 raised power minus 1. So this and this will go. Therefore, s equals to 2, or this and this will go. S equals to 1. So that's how to solve that, as very simple as that. Okay. So we are going to stop our indices, or the topic indices, here. Though we are moving to logarithm, there might still be a simultaneous equation where there will be a combination of indices and logarithm. Okay. So please do well to subscribe to our channel, share our videos, and give us a thumbs up. Okay. So see you in the next class. Thank you.